In this recording, I want to look at an important convention concerning function composition notation that is used throughout modern algebra, but it's not that common in the rest of mathematics. But before starting to look at that convention, I want to actually review the function composition notation that you're familiar with. In courses like your calculus and your high school mathematics courses, as well as courses like differential equation and real analysis, function composition is usually written as f circle g, and then we apply it to x, and the meaning of this is f of g of x. This side is often read as f circle g or f composed with g. This side over here is usually read as f of g of x. And the important thing is that this side makes it clear that the meaning of function composition when it is written in this f circle g notation is that we first do g, then do f. So in this abstract algebra class, because we're often not going to be focusing in on the arguments, we're going to see a lot of f circle g's, but the important way of reading it in this class is first do g, then do f. And in fact, when you look at the way I write these things, I'm often going to be actually writing it backwards by saying such things as first do G, then do F. In other words, I will actually write these compositions backwards. Now, it's important to realize that in a course like calculus or differential equations, or real analysis, or a lot of other courses, there are needs to do two things. We need both composition, and that notation is the usual f circle g notation, and we also need multiplication of functions, which is usually written as fg, and fg of x in a calculus class is f of x times g of x. So just as a real quick example from calculus, if f of x is the sine of x and g of x is the natural log of x, f circle g would be applied to x, and that would be f of g of x, and that would be the sine of the log of x. And fg of x would be f of x times g of x, and so that would be the sine of x times the log of x. Well, in modern algebra, we will never need multiplication. And I'm going to actually write that down. So in abstract algebra, we never need to multiply functions together. And because we are never going to multiply functions together, we have a convention in abstract algebra that we will shorten first do G, then do F notation as first do G, then do F without using the circle in between the two letters. So it's important to realize that in your abstract algebra class, symbols like first do G, then do F always mean first do G, then do f if f and g happen to be functions. And if we turn it around, first do f, then do g, this is first do f, then do g. And we can get away with this in abstract algebra because we never need to multiply functions.